completing the square and proving the quadratic formula. Let's work through a few simple examples. Consider the equation x squared equals 7. Solving this equation isn't so bad. You would take the square root of both sides. Square root of x squared is plus or minus the square root of 7. So we have the solution for x. X is equal to plus or minus radical 7. If I make the equation slightly more difficult, x squared plus 1 is equal to 7. Well, what we'd do is subtract 1 from both sides. We'd obtain x squared is equal to 6. Then we can proceed as before, take the square root of both sides, and obtain x is equal to plus or minus radical 6. An even more complicated equation, 2x squared plus 1 equals 7. As before, we subtract 1 from each side. That gives us 2x squared equals 6. Then we can divide both sides by 2. And that leaves us with x squared equals 3, which then becomes x equals plus or minus radical 3. In each of these examples, our goal was to come up with an equation where a perfect square equals something, a perfect square equals something, a perfect square equals something. Then we just take the square root of both sides. Don't forget that plus or minus, and we have our solution. Now let's look at a much trickier example. Let's consider x squared plus 6x plus 9 equals 0. Now it turns out that this left-hand side is a perfect square. It's the perfect square of the algebraic term x plus 3 squared. In other words, this term factors very nicely. Well, we have a perfect square on the left. Just as before, we can take the square root of that equals plus or minus the square root of 0. That's kind of silly. This right-hand side is still equal to 0. And x plus 3 is equal to 0. Or in other words, x equals negative 3. Well, we were pretty lucky there. The left-hand side looked like a perfect square already. Let's do another problem. Let's try x squared plus 6x plus 9 equals 7. The temptation is to combine like terms, move the 7 over to the left-hand side. But in this case, because the left-hand side is already a perfect square, we want to leave it as it is. So, on the left-hand side, again, let's factor. We have the quantity x plus 3 squared equals 7. As before, we will apply the square root to both sides. X plus 3 squared. Square root of that is our plus or minus radical 7. And simplifying, we have that x plus 3 is equal to plus or minus radical 7. Or in other words, x is equal to negative 3, subtract 3 from both sides, plus or minus radical 7. So again, if we have a square on the left-hand side, solving these equations isn't so bad. Now for a slightly trickier one. What if we had x squared plus 6x plus 8 equals 7? Well, this isn't a perfect square over here. If only that 8 was a 9. But with the powers of algebra, we could. Let's add 1. But if we add 1 to the left-hand side, we must add 1 to the right-hand side. This leaves us with the equation x squared plus 6x plus 9 is equal to 8. Then we proceed as before. X plus 3, quantity squared, equals 8. Taking the square root of both sides, x plus 3 is equal to plus or minus radical 8. So x, in this instance, is negative 3 plus or minus radical 8. So if you don't have a perfect square on the left-hand side, try to turn it into a perfect square, for then you can factor, take the square root, and find the solution.